Hello viewers, in this video I'm going to be sharing with you how to differentiate inverse trigonometric functions. Now this is how to differentiate it. Now if we look at this, we notice that the first thing we need to understand is we need to have knowledge on trigonometry and then know the trigonometric identities, of which I'm going to show you how to get some of it here. Though if you've not watched my video on trigonometric identity, you go over to a playlist exam trick, or you go under trigonometric identity and you watch it there before coming up to use the identity in this particular question here. All right, so let's move into it. Now on the board here we have example like y equal to sine inverse of x, y equal to cos inverse of x, and y equal to tan inverse of x. So we're going to start with the first one, y equal to sine inverse of x. Now how do we differentiate define the dy dx of y equal to sine inverse of x? Now look at this. Whenever you are given a question like y equal to sine inverse of x, I want to show you something. This sine inverse of x is the same thing as what? X all over sine. It is the same thing as x. So don't forget this. So this is the same as now y is equal to what? X over what? Sine. So mathematically, what you have to do from here is to cross multiply. And once you cross multiply, what you have here is what? Sine y is equal to what? X. So this is what you have. So from here now, you move over to another step of differentiating your sine y equal to x. You differentiate it. So from here, we're going to find our ddx of sine y. And then over on this side also, we're going to find our ddx of what? X. All right. So finding our ddx of this, now we'll notice that if we differentiate sine over here, anytime you differentiate sine, you get what? Cos. So this gives us what? Cos y is now equal to, this is dx over dx is same as what? This cancels out, is same as what? 1. So this is same as 1. So we have our cos y is what? Equal to 1. All right, that's good. Now next thing is to remember your trigonometric identities. Now there is a trigonometric identity that states that sine x plus cos x is equal to 1. So but then this trigonometric identity, due to we're dealing with y over here, we can decide to just say let this change this to from sine x to what? Sine y to what? Cos y. It is the same thing. I just want to show you that you can easily just manipulate this from here. It is the same thing as sine y plus cos y is equal to 1. All right. So meanwhile, we're not leaving it at this point, because what we need actually is that we have to square them. We have this to be squared. All right, because what now we have a sine square y plus cos square y is not equal to 1. So this is the exact one we need when differentiating inverse trig functions. All right. Now from this point, what we have to do is that we have to recall that since we have this to be sine y equal to x, that is to say if sine y is equal to x, then how do we get this one here? How do we get sine square y? That means it have to be what? Then sine square y will now be what? X squared. Hope you agree with me. So there's it. So if just sine y is x, that means sine square y is going to be what? X squared. So that is true. So if it is so, that means we're going to replace this particular value for sine, that is x squared, in this particular expression here, or in the identity, so that we should see what we're going to get. So replacing it now, we're going to have this to be what? X squared plus, this is our cos square y is equal to 1. So from here we take x to this other side, it becomes what? Cos square y is now equal to 1 minus what? X squared. All right. So having this now, we have to find apply square root to both sides. Now applying square root to both sides to remove the square on the side of this cos, that is squared cancel out, this square root cancels out. So what we have now is what? Cos y. We are now having cos y is now equal to square root of 1 minus what? X squared. So this is what we'll have our cos y to be. Now meanwhile, I want you to look over here again. You notice that we said our cos y is equal to 1. All right. So here we have that cos y is now equal to square root of 1 minus x squared. So we're going to use this 1 minus x squared and substitute it for what? Cos y, since that is the value for what? Cos y. So we're going to use it here now and substitute. Now in substituting this, we're going to have, so then here is going to give us, we have the value of cos y to be what? Square root of 1 minus x squared. Alright, I will say it's not equal to 1. Alright, but now we're going to find the dy dx of the whole thing here now. So we're going to find the what? Dy dx of this. Alright, so finding the dy dx of this is same as dividing both sides by square root of minus 1. So divide this side by square root of 1 minus x squared, I mean. So divide 1 by square root of 1 minus what? X squared. So from here you notice that your 1 minus x squared, square root of this cancels out. So your dy dx, according to what we're asked to find, is now equal to 1 all over square root of 1 minus what? X squared. You can check it anywhere, Google it, you're going to get this same answer. Alright, so this is exactly how to find your sine inverse of x. So now we moved over to the next one, cos inverse of x. Now the same step applies to this particular one also. So what are we going to have now? If I say cos inverse of x, I say the same thing as saying what? X all over cos. Alright, so this now y is equal to x over cos. What we'll do from here is simply to cross multiply, and then what do we have from here? From here we're going to have that this is now cos y is equal to, now what is our cos y is equal to now what? X. Alright, so this is what we got. So from here we're going to differentiate this first of all. That is to be what? Find the d dx of cos y. And then also at this side we're going to find d dx of what? X. Alright, so finding this now, I told you earlier, you need to also know what happens when you differentiate cos. Now once you differentiate cos, now meanwhile, if you have not watched that video, go over to, I said, differentiating trig functions. You're going to see, not inverse, you're going to see a video titled differentiating trigonometric functions, not inverse. So you watch that video and you're going to know what I'm doing here. Now this is what? Cos y, if you differentiate, you're going to end up with what? Minus sine y is now equal to, once you cancel out this side, differentiate x is still as 1. So you have this now. So the next thing to do is also recall that trigonometric function we stated earlier. So that what? Sine x plus cos x is equal to 1. And I say you can target to be what? Sine y plus cos y is equal to 1. You can then you now square them, apply square to both sides. So what we have from here now is that we now recall from this point again that cos y, if cos y is equal to x, then cos square y is going to be what? Cos square y is going to be what? X squared. Alright, so we're going to put this x squared into this for the value of cos. So we're going to plug it in there. So plugging it in there, we're going to have this to be what? Sine square x plus x squared, then it's equal to what? 1. So let's make x sine square x subject to the formula. Sine square x is now equal to 1 minus x squared. So to get our sine x alone, we're going to square both sides, apply square root on both sides so that this one can cancel out. So we have this to be what? Sine x is now equal to square root of what? 1 minus x squared. Alright, so we are actually we are just at the point, there's a point we were at this that is the same with similar to this sine inverse of x. So this cos inverse of x, same step with the sine inverse of x. So what you do from here is now what? You have a sine inverse of x, and you know that you have gotten this value now. You got this particular value for what? Sine x. So you now go over here now, you look at this. What you have here, okay, let's use y, let's use y. Let's apply y to this point here. Alright, so this y. So we'll now come over here, we'll notice that we said that our sine y is equal to 1. So we're going to plug in the value for x. So this gives us what? Minus, now let's have it on this side. Minus, sine is now what? Square root of 1 minus x squared. And remember, you are finding the dy dx of this. Dy dx of this particular one here is now equal to 1 over here. So what you do from here is that you divide both sides by square root of this minus square root of 1 minus x squared. You divide this 1 also by minus square root of 1 minus x squared. So this is what you do. So from here now, you notice that minus square root of 1 minus x squared cancels out this particular one. So on this side, you are left with dy dx is now equal to what? 1 all over minus square root of 1 minus what? X squared. So this is what you get for what? Cos inverse. So look at sine inverse. It's just different between the sine inverse and cos inverse is the sign. The cos inverse has minus at the base, and the sine inverse doesn't have anything like minus. Now let's go over to the next question here. We have tan inverse of x is same as what? X all over what? Tan. So this y now is equal to this. So to find to go further from here, you cross multiply as we did earlier. So this becomes tan y is equal to x. All right. So from here now we're going to differentiate. We're going to find d dx of tan y, and then we're going to also find d dx of x. So d dx of tan y, when you differentiate tan, you're going to end up with what? Sec square y is now equal to, differentiate this to x is going to give you what? 1. So sec square y is equal to 1. So next thing is to recall the trig identity that says sine x plus cos x is equal to 1. So now from here we're going to do the same thing now, but we're going to just put it to be y, change this, put squared, make this to be what? Y, then apply square. All right. So what we'll do from here is divide all through by what? Cos square x. So divide all through by cos square x, and divide this by what? Cos square x. I'm only trying to show you how to get another trig identity. Now why do we do so? Because tan, we know that tan is giving us what? Sine over cos. So we want to actually achieve sine over cos over here. So from here we'll cancel out cos to give us 1. So this is equal to inverse of cos is going to give us what? Sec. So this is now sec square x. So from here we'll have that what? Tan square x plus 1 is going to give us sec square x. Now meanwhile, you know that we already got our sec square x here, to sec square y, I mean, to be what? Equal to 1. So what we'll do from here is the same thing. We go over here and we'll now say, okay, now if tan square y, if tan y, I mean, if tan y is equal to what? X. That is from this point over here. If tan y is equal to x, then tan square y is equal to what? X squared. So we'll do the same substitution at this point. So we're going to end up with what? We have that x squared is x squared plus 1 is now going to give us what? Sec square x. So we do the replacement over here, knowing that our sec square x is equal to 1. So we're going to replace it with what? We now have our x squared plus 1 as sec square x. Now then find the dy dx also is now equal to what? 1. Divide both sides by x squared plus 1. So this is now x squared plus 1. You are dividing both sides by it. So you end up that this cancel this. So you have your dy dx to be equal to 1 all over x squared plus 1 as your tan inverse. So thanks for watching this video. Do well to subscribe to this channel. This is Extreme Learning website, and will have your best interest at heart. See you in my next video. Thanks.